When I was younger, my dad always fixed the family car first before taking it in for service. He had been a mechanic in his youth, so he'd changed the oil, changed the filters, changed the hoses. Imagine being able to hack a vehicle today. They're more computer than mechanical beasts. In recent years, the automotive industry has undergone a significant transformation, evolving from mechanically driven systems to complex software-driven networks. As cars become more connected and interconnected with technologies like automotive, Ethernet, and telematics, the need for robust security, well, it's become paramount. Well, then there's the impact of legacy architectures, the difference in design approaches between European, American, and Chinese automakers. Initially, automotive systems relied on simple electronic control units, or ECUs, and CAN buses. But now, cars are complex. The industry is catching up with security standards, but challenges remain. Research into automotive security has grown significantly in the last few years, with increasing public research and interest from universities and independent researchers. However, much security research remains private as vulnerabilities get fixed without public disclosure. And modern ECUs, they now run on popular operating systems like QNX, Linux, and Android, particularly for entertainment systems. In this episode, I'm talking with an independent researcher who's made great progress in hacking automotive systems on his own. This is the story about what automotive hacking is like today and how hardware hacking is leading the way. I'm Robert Bamosi. This is Error Code.
I am Alexander Pick, and I'm a security researcher.
So ordinarily, I have my guests state an elevator pitch for their companies.
I'm working independently nowadays.
As an independent researcher, how did Alex get started in hardware hacking? Unlike software, which you can hack from a basic laptop, did Alex have to go and buy a lot of equipment up front? Or did he, just start with a few pieces of equipment, then build from there?
I mostly grew my equipment. I just used some of the more common, cheaper tools. And then with more and more projects, I built up a quite impressive lab, I think. I now have a complete home lab at home with a lot of more sophisticated hardware and hardware hacking stuff and soldering stuff. And so I think you have to build it up a little bit. If you want to start out with it, some cheap UART adapters and stuff like that. Maybe a JTAG debugger are good if you want to start out. But after a while, you need more sophisticated tools. And I built that up over the time. So it's quite a lot of stuff now. My wife didn't like all this stuff in the house always. So I had to put the stuff I don't use in the garage. I already have a room with all kind of equipment now. So it's you need a lot of stuff if you do a lot of hardware. But for starting out, some of the simple tools are pretty nice. Nowadays, you get hardware hacking tools on a single PCB, which are quite good for starting. These are good to go. And the targets, most of the time, if you, for example, do a bug bounty, if it's not a contracted engagement, you have to buy the hardware. That's the drawback. But most of the time, it pays off. So,
Bug bounties are when a company offers to pay hackers if they can find vulnerabilities in a given service or product. It's an open invite to come and hack. A few have managed to make upwards of $1 million with this, but those individuals are very rare. In general, you can make some money doing bug bounties, but not a lot.
Got my first big bug bounty with an automotive vendor. Was really impressed that you can now earn money with it, and then started out to do bug bounties in my free time. And then I decided to completely shift my professional career. I quitted the company I worked for, and then I applied for various security roles and found a really good role with an really, really big automotive enterprise. I worked there for quite a while, doing security research, in-house security research, with a lot of success. But somehow, since I was self-employed before, I really wanted to get back into self-employment. I put myself on a half-time position. So I cut my hours and started to work on my own company. Started to do a lot of bug bounties and find some customers. And now I'm 100% independent security researcher, and I only do hardware and a little bit of software, just a little bit to fill my time. But it worked out, and I'm quite happy with it.
And then there are a couple different ways you can approach hardware hacking. There's non-destructive, where you passively listen to chips, and then there's destructive, where you strip off the resin and grind the chips to expose the circuit board underneath. For destructive, Alex, like others, has to have more than one piece of hardware to work with. In this case, at least 3.
Normally, I try to get, if I do a professional engagement, I try to get 3 samples of the device. So I have one I can take apart. I can unsolder parts to identify them, to see if I can dump stuff off an eMMC or something like that. I have one sample I want to keep as a backup, and one sample I use for validation of possible findings. I think the best or the most challenging part is trying to get off the software firmware from the device. You need to dump it in some way that can be using JTAG, SVD, or other debug interfaces. Sometimes you have UART interfaces you can use to interact with the device. You need to find a way to access the firmware. Hope that there's something left for what was overseen, like there's no readout protection or something like that, so you can dump the actual data of it, and then you need to go do reverse engineering. That's a big part of hardware hacking, is always reverse engineering. There's the hardware part, which is a lot of electronics, understanding how PCBs are designed, how hardware architecture works. On the other hand, you need to have a lot of experience with software reverse engineering, especially on highly integrated systems. That's quite important.
Staying with hardware for a moment, for destructive, even some non-destructive testing, did Alex try and obtain more than one device? Did he go to eBay and other auction sites to buy the devices as inexpensively as he could?
Yeah, that's one of the things which is pretty common in hardware hacking. Doing research on various auction platforms on the internet, like finding used devices. If, for example, we worked on a project which was around mobile networks, and the hardware for it is pretty expensive. You cannot just go and buy it off the vendor. You have to find these stuff on auction platforms. There's a lot of it, actually. You just need to look around, and then you can identify the pieces you need. And I really assembled a complete base station in my garage just to do research on it. Obviously without antennas, so it doesn't send anything, but that's good enough for the research part, and it worked out quite well. So getting this stuff secondhand is one of the really important skills you have to learn over the time.
And not all the firmware has to be extracted. In some cases, you can actually download the firmware from the vendor's site.
Yeah, that's very good if you can. Nowadays, a lot of vendors encrypt their software firmware updates, so that's for at least the very or the vendors with a higher security requirement. It's a must-have to encrypt the firmware. So you need to find a way to decrypt it. That works sometimes if you find keys or something, maybe in updaters or something, floating around the internet. If it's a lower security device, maybe a router or something like that, you can just download it, binwalk it, and quite often you just get a firmware out of it. And it really depends on the vendor. It really depends on the target. Automotive, for example, there's a requirement to encrypt stuff, so it's 99% of the time it's encrypted. For other stuff, you really need to try it out if you can find firmware. Sometimes it's you first need to find the update servers or something like that, because it's not directly downloadable, so you can just get it from the update server. That's also a way to get software. Yeah, it really depends on the target. Needs some time and evaluation for each target you're approaching, but it's one of the first things I'm doing if I do the recon in the early project stage. I'm looking what can I download. Is there a public download? Is there maybe a public download with a supplier I can use, or is there something which is floating around the internet just as is? Sometimes you find stuff even with some support websites companies buying off the vendor, offering the firmware on their support website, even if they shouldn't do that. So you can find it there. It's a lot of looking around the internet and finding stuff. That's one of the very first steps in the recon stage.
CVE stands for Common Vulnerabilities and Exploitation. These are vulnerability disclosures that are cataloged and available for everyone to see. I've used the list to tell me how many hardware vulnerabilities there were in a given year, or how many Modbus or MQTT vulnerabilities were listed. The list is not exhaustive. There are vulnerabilities that are under NDA and don't get listed unless somebody else discovers them. And sometimes companies just don't want their dirty laundry made public.
After CVE was introduced, they reassigned CVEs for submissions on the bug fix mailing list. And these are also my first IoT-related CVEs from 2001. Mostly around the IPC chip. That was a device which was sold as a starter kit in the German CT, that is a really well-known magazine. And I ordered one of these starter kits and started to play around with them. It was mostly meant for home automation or industrial automation. It was like a little computer running some system which was it was like MS-DOS, but some own development by these guys, and I found some vulnerabilities there and reported these. And these are my first IoT-related vulnerabilities.
So again, when I was looking at automotive CVEs, I found a lot of cryptographic stuff was vulnerable. And it could be that the automakers were attempting to roll their own encryption, which is something you should never do. Did Alex find that cryptography was low-hanging fruit when he approaches an automotive project?
I think it's not just a low-hanging fruit for automotive. I think it's a general an issue with all kind of hardware and hardware development, because people doing this integration on the developer side are not always security engineers. They might be supported by security engineers, but crypto leaves a lot of room for failure. Either you might mishandle the keys, or you do improper key generation. Even consoles. If I remember the PS3. I think there was a big issue. The failover group found this key being generated on a non-random, so they could just recalculate the key, and this was like the hard piece of their rights management. So essentially, crypto always leaves a lot of room for error if you're not really careful with integrating it. If your key generation is somehow flawed, or if you try to use a hardware security model and keep your keys in memory or stuff like that, there's so much what could go wrong. Crypto is always a thing you can look into if you're doing security research, and it's quite often paying off, because there's so much what can possibly fail, or how you can get the keys. And once you have the key, you have the key to the kingdom. It's if the key is meaningful and has some power, then you're all set.
So other than crypto, are there other soft targets that Alex looks for when he starts his research?
Yeah, I think one really interesting thing to look into is always the patch gap, because it's for all hardware devices. One thing I like to generally look at is when those roll out updates, but the updates might still include a lot of vulnerabilities. They are slow in rolling them out. So even if you cannot get access to a device or also for an ECU, in first place, you can wait a little bit to see if there's a CVE popping up somewhere. If a CVE allows you, for example, it's a memory corruption thing, stuff like that, and it's possibly exploitable. You can try to use that to access the system, and that's will give you initial access. So I think patch gaps are even especially in automotive a thing to look at. Otherwise, it really depends on the ECU. So ECUs are nowadays built on modern operation systems most of the time, at least the interesting ones, reaching from QNX to Android to Linux. It's interesting to look into all kind of vulnerabilities which are very much related to one of these operation systems.
Here's where knowing software as well can be very useful in hardware hacking.
I went into software development because security wasn't a thing back then, and you couldn't earn any money with security back then. It was mostly a hobby. And people even asked me why I do that. I couldn't explain it back then. It was interesting to me, so I did it. And then I became a software developer.
This is all too common. In the last 20 years, software vulnerabilities have been all the rage. Hardware, not so much.
In that time, I also was mostly active in software stuff, and also did some reverse engineering. That was what I did privately, but the stuff I did on the mailing list was also private stuff I did. Still, I kept up with all these hacking topics in my free time. I did a lot of stuff in the Hackintosh world, later with iPhone, consoles, and stuff like that. And it more and more moved into this hardware direction. It also moved into the hardware direction because in my professional life, I went more and more into embedded development and was self-employed for a longer time. Then I became employed again and moved up into management. That wasn't really interesting to me, but I did a lot of aerospace and defense stuff back then. And then I somehow discovered that, security, especially in embedded, is now a field with a high demand.
I'm interested that as an independent researcher, how do you get started in automotive? I mean, you can't really go out and buy, say, 3 cars and use them for your research, or can you?
If you want to do automotive, most of the time you will try to get some ECUs, also of some auction platforms. They're really good finding these. Get some ECUs, play around with them. You will notice that sometimes ECUs won't work just as is. You sometimes have to supply them with other ECUs, so you need to kind of interconnect them. That's possible. There are even some kind of bus simulations nowadays you can get even on the internet, mostly made for repair shops and stuff. Or you have to find a car to play around with, but finding a more recent one is pretty hard. So you can maybe try it on your own if you want to try it, and if you're sure you can't break it. But getting off, for example, an infotainment head unit from an auction website is the most viable way to go and start off. You will encounter a lot of stuff on these, let's call them higher level units, because they are on like Linux, QNX, Android, and stuff like that. And you will encounter a lot of things you will encounter with a lot of other vendor units as well. Even you get an older unit, they're easier to hack. Maybe you find some stuff on tuning websites, how to access them. So they are good for learning. If you want to approach a really recent one, you can expect much higher security measures, and you need to find your way around that. So for learning, an old unit is okay. For going into the most recent devices, you need a little bit of preparation with the older ones. But since they are built up on each other, it's once you know one of them, you know a lot of them. That's really important.
So software in automotive is relatively recent. I mean, they did have ECUs back in the 1970s. And for those ECUs, they needed to build a CAN bus to communicate. They had very simple systems for the longest time. Now, all of a sudden, we're connecting cars to the internet, and it's doing telemetry back and forth. I'm wondering, is Alex finding that the industry is rising to the challenge, or are there still a lot of learning curves to be had?
Actually, they are good in trying to catch up, especially because there are a lot of new compliance requirements like UNECE. They have to follow these, so they really try their best. I think automotive has, compared to other areas, a really high security standard nowadays. Still, it's a really distributed system. You have a lot. It's essentially it's a network on wheels. So it's pretty complicated. Firewall routes might be super complicated, multiple thousand rule sets and stuff like that. So there's a lot of room for error, and there are just a few people looking at it outside of the automotive companies. So you can expect a lot of people have tested that internally, but sometimes people from the outside have different views on things. And so it's interesting to look at. You can expect a lot of high standards, a lot of really sophisticated and recent measures, but you can also expect to find holes and sometimes also let's call it non-standard architectures because of various reasons. You need to get familiar with all the automotive bus systems, automotive Ethernet being one of the most important ones on CAN. Maybe also Linbus, but it's not used much anymore. And yeah, you need to really see your car as a network, and you need to approach it like that. So that's the thing. The automotive vendors will protect their network. So yeah, be ready for a challenge here.
Then again, automotive is kind of a mess. The OEMs, the brands that you recognize, the dealers that you go and visit, they're actually the end product. There are a lot of vendors, tier 1, tier 2, tier 3, that make up the components in the car that you want to drive off the showroom floor. I'm wondering, is Alex finding more common mistakes given the large ecosystem? Common things like protocols or communications, that type of stuff that is more, say, systemic to the industry.
Automotive is really an ecosystem on its own. A lot of people think that automotive hacking is still something like replay attacks or CAN bus replay or something like that, but it's far more sophisticated. If you really want to break a car network, you need to go on automotive Ethernet. And if you are on automotive Ethernet, you are essentially in a network. You have IP46, and you have a lot of interconnected devices. You have a lot of traffic. You find a lot of services, and it's a real interesting kind of environment, and you need to move around in it and see what you can find. It's different to what you might expect in first place. You will find, and sometimes you will even find operation systems you hardly find anywhere else, or system architectures you won't find anywhere else. But on the other hand, it's also using a lot of standard components. And yes, these are recent if they are in the making and if they are in the prototyping stage, but ECUs are made to run for a very long time, multiple years. So also take a look how often they are updated and stuff like that. So it's a long running like an LTS system. Let's call it like that.
So internal combustion engines or ICE vehicles, and then I'm assuming hybrid, they're going to be similar in a lot of ways. But I'm wondering, are electric cars different? I mean, do they still need a CAN bus? Do we still need Ethernet? Or are they still based on those legacy ideas in architecture?
It really depends on the vendor. If you look at the European vendors, they have this historically grown ECU ecosystem, which is a lot also developed by various suppliers. So changing this architecture is pretty hard for all of them, because if you would change the complete architecture, this means that you need to not just redesign it, you need also to redevelop a lot of stuff, which you might reuse from previous developments. So you would break the entire development and need to start off. Especially the European automotive vendors are having hard times doing that. If you look at some of the American vendors, they have a complete different approach in designing their car. They designed it around a computer. They built actually a computer and built a car around it. The European vendors built cars and then built computers into the car. So this different view created different ecosystems and different systems to work. There are a lot of things which are standardized, like CAN, because it's a standard in automotive, and you use it because it's there. Automotive Ethernet being the same thing. So you will encounter the same technologies, but from the architecture, there are a lot of differences, especially now with some Chinese vendors coming in. Chinese vendors add a new view on things. They do rapid development. They try to make things very simple so they work, and also create new architectures themselves. So you have now a very, you have a lot of different approaches and systems, system architectures. It will be interesting how this works out in the next 10 years. At least for the mass market, the European architecture is one of the most widespread for the normal gas vehicles. For hybrid, it's the same. Even for electronic vehicles from Europe, it's the same. So the architecture itself stays like that until somebody really does something new, and that mostly happens because they do a buy-in. I don't see that any bigger European vendor will just change their architecture overnight. It's too difficult to do, especially with the people working on it. You would need to introduce too much new technology to new architecture stuff, and it's really hard to do. In the American market, at least one or two of the vendors over there, they have their architecture they work with and like. Yeah. So we will see what will be more dominant in maybe 10 years. At the moment, it's pretty fragmented.
So this diversity, it kind of sounds like it would be ripe for the hacking community to attack. And I don't mean that in a negative way. I just mean start exploring.
Actually, we see a lot of automotive research in recent years. There are a lot of people, also some people I work with on bug patches, for example. Leonard did a lot of Tesla research. So people are doing a lot of automotive nowadays. It really increased in the past 5 to maybe 6 years. 6 years ago, I can't really remember seeing any meaningful research or any meaningful stuff presented at conferences. Nowadays, they even present really in-depth stuff. There was one thing in Black Hat UK like this year and last year about one of the bigger European OEMs, which was really interesting to see, and we're going really in-depth. And I think we will increasingly see that because the security research community also diversifies a lot nowadays, and they go into new fields. Automotive always had the problem that you have a high entry barrier. You cannot just buy a car, but now some people found out that you can just actually buy an ECU, or they go and work for a company which says, okay, let's do some research and let's buy a car. So the companies have some spare money and just sponsor it to get all the required equipment, and that increased the amount of public research and also recent research a lot. And also universities are now in the game. Like the Tesla hacking stuff is a lot done at universities. It's quite interesting because they have maybe not, they cannot just buy a car, but they also have a lot of equipment and really good equipment laboratories to work on this. So there are now a lot of more players in the game, and I think we will see a lot more people going in it.
So maybe a year and a half ago, I looked at CVEs that were specific to OEMs and Tier 1s and Tier 2s, and I tried to figure out if there were more hardware or software-based vulnerabilities being reported. And what I found was it was pretty evenly split. But overall, I found that it wasn't very populated. In other words, people weren't exactly reporting their CVEs in the automotive industry.
There is a lot of stuff which is not made public. Also from security vendors. Some Chinese vendor I know quite well is reporting a lot to European automotive vendors, and they are mostly out for getting contracted. So if they get contracted, they won't publish their research, and that kind of stuff is around for a long time. So sometimes you won't see this because the companies simply get contracted by the OEM, and the research will never see the light of the day. But increasingly people are working on it, and increasingly stuff is found, and so increasingly stuff is published. And I think it will, at least in the next few years, with all the electronic vehicle hype and stuff like that, we will see a lot more things.
So given that some of these are under NDA, I'm wondering, are there collisions? That means when another researcher finds something and isn't under an NDA, so that researcher can report something that was previously found, but say the company didn't want it to be disclosed.
That might happen, but most of the time, if something is found, it's this kind of stuff takes time to. Yeah, actually, if you want to find something on an ECU, you need to take some time for that. If there's a collusion between a publicly researcher independently finding a vulnerability and reporting it, and some company finding a vulnerability and reporting it, I'm not aware that happened in the past, to be honest, and I've seen a lot. Most of the time, these are different findings, even high serenity findings, but they are always in different ECUs. So there's not so much research that there are bigger collusions at the moment. Most of the time, the stuff reported and also published is in different places. Sometimes researchers try to pick up research from a previous presentation or previous published vulnerability. I've seen that before. So there's, for example, some researchers found something in a specific ECU, and other guys picked up that specific ECU after it got fixed and found another vulnerabilities. That's something what happened. So they build up on the research of the previous published paper. But I'm not really aware of any collusions at the moment.
Flipping that around, you're an independent researcher, and you go to approach a vendor with a vulnerability that you found. Do you find them to be receptive, or are they unprepared to deal with a researcher bringing them a vulnerability or potential vulnerability out of the blue?
Since I worked on the vendor side as well, it really depends. Sometimes most automotive companies are big enterprises. It's the same thing if you are an independent researcher and trying to report a big enterprise. Most enterprises nowadays have contacts for that. How it's handled internally is a lot dependent on how big the enterprise is, how this vulnerability is passed along the enterprise. You might report it to the mother company, and then it's passed down to a supplier. Supplier might write it independently, but it's the very same thing with automotive companies and some tech companies. It's the stuff you deal with being a security researcher, trying to find the correct responsible and trying to make them fix your stuff. I think automotive vendors nowadays are on the same level as most other tech companies are.
Alex mentioned that with the chips getting smaller and faster and smarter, ECUs, well, they're getting smaller, faster, and smarter as well. So we're likely to find Android and QNX in automotive Linux and so forth in ECUs today, and not the legacy proprietary systems.
All ECUs I have looked into in the past years are mostly built up on one of the, especially higher ones. If you have an infotainment system, you can be very sure that it's not an entirely own developed system. It's either QNX, Linux, Android. These are the most common three. There's sometimes if you have ECUs which run like a 4 kernel, maybe if they are lower tier ones, only the really small ones, the ones which run, which are what I would call a low-level ECU, which runs the code directly. These are a little bit different. They will still run some kind of RTOS, but for the higher level ones, you will always encounter one of the well-known systems. And I think it goes at least 10 years back that this kind of stuff is either Linux, QNX, and nowadays it's Android. So these are the main three systems you will encounter.
So is automotive hacking still a niche in the industry today?
Yeah, people really need to look into it because I think it's still underrated, and I still think that there's a lot of things you can find, and also the network topics are quite interesting. Not just looking at one ECU, especially looking at the communication between ECUs. If you have multiple ECUs talking to each other, via Automotive Ethernet, using the gateway and stuff like that. Really look into the entire system, not just one part of the system. And I think there is a lot to explore still, and I'm sure that one or two people are already working on it, but it could be more than that. And I hope that we'll see some good research in this field at some point.
I'd really like to thank Alex for coming on the show and talking about automotive hacking. Our conversation, got into the technical aspects of automotive security, including common weaknesses in cryptography and the importance of patch management, with a focus on security of electronic control units and the shift towards modern operating systems. Well, that leaves experts like Alex to explore the evolving landscape of automotive research. As the automotive industry continues to adapt, the need to continue to have vigilance and collaboration in addressing threats becomes all the more important. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. I'll have a conversation about hacking solar panels, and also more on hacking water facilities. Subscribe today. I don't want you to miss out.